All right, so last week we talked about solving rational equations and when we're actually solving them. So we're actually finding a value of x. And it was pretty straightforward for us last week because we could just use the cross product. So we didn't have to worry about least common multiples. We could use the cross product, and then we would usually make a linear equation where we just solve for an x and we have to check it. Sometimes we would have an x squared term. So if you have an x on the top, and an x on the bottom, you'd end up with an x squared term. And in that case, you might have to check two different answers, right? We'd have extraneous solutions. And hopefully you notice, like we pointed out last week, that the only time it's not a solution really is when you plug it back into the original and it makes one of the denominators 0, because you can't divide by 0. So today we're going to talk about example 2, and I'm actually only going to do example 2a, and then I will do the rest of the example tomorrow with everyone. But I just want to kind of get your toes wet here a little bit with these ones. So still the same idea, we're solving the equation, we're checking for extra solutions. But now notice, last week we were in this form where it was a fraction equals a fraction. Now we have two fractions, or a number and a fraction, on one of the sides. This prevents us from using the least common multiple. I'm sorry, it prevents us from using cross multiplication. We have to use the least common multiple. So we're back to what we did in section 5.4 and 5.5, where we have to find a least common multiple, and you might have to find a least common multiple of multiple things. So you can rewrite this equation as 1 over 1 minus 8 over x minus 5 equals 3 over x. So if you look at all three denominators, our least common denominator or least common multiple would be x times x minus 5. So then what you can do is you're going to make these all have that least common denominator. So you're going to have x times x minus 5 over x times x minus 5 for this one. This one almost has that least common multiple. But we'll do x over x, and over here we'll do x minus 5 times x minus 5. Much like our complex fractions, once you have this set up here, you can really just eliminate this bottom part. And what you're left with is 1x times x minus 5 minus 8x equals 3 times x minus 5. Multiply in, so we're going to distribute in this 1x and this 3. So you'll have 1x squared, and really you don't need the 1 there. Just write x squared minus 5x minus 8x equals 3x minus 15. If we combine like terms here, we have x squared minus 13x equals 3x minus 15. If you subtract the 3x and add the 15 over to both sides, and remember you have to do this anytime you have an x squared and an x, then you'll end up with x squared minus 16x plus 15 equals 0. Anytime you have this x squared plus or minus an x plus a number or minus a number, this is where you should think factoring. We don't have to do factor by grouping because it's just an x squared. So what multiplies to 15 but adds to negative 16? Well, that'd be negative 1 and negative 15. So our multiples, our factors, would be x minus 1, x minus 15. If you take each of those factors and set them equal to 0, you get x minus 1 equals 0, x minus 15 equals 0, so you get two solutions, x equals 1 and x equals 15. Now remember, if you plug either of those into the original equation and you get a 0 on the bottom, that means it's not going to be a solution. In this case, plugging in a 1 or a 15 does not break this equation, right? It won't make you divide by 0. So these are both going to be solutions, and you can verify that by plugging in. And especially if you are taking a test or a quiz and you have time to go back and do those like more thoroughly, for sure, you should definitely plug them in. I'm going to skip plugging them in just for your notes because I'm sure most of you will just tune out at that part anyways. But again, you can just plug it back into the original equation and verify that, yes, these are both solutions.